we're now going to be talking about critical values, and critical values are crucial pieces of knowledge for the AP exam. So let's go ahead and take a look and see what this is all about. Well, the first bullet says that if the function f of x is defined at c, and either f prime of c equals 0 or f prime of c does not exist, then that point c is said to be a critical x value of the function f of x. Okay, so let's think about this. The function needs to be defined, okay? It must exist at that point c, and the derivative is 0, so we're probably going to have maybe, let's think about this, a function that looks like that, suppose, or like that. The derivative must have some kind of horizontal tangent, so perhaps a local min or local max. All right. Or the other case is that the derivative does not exist. So let's take a look. Let's illustrate that. Suppose we had some kind of cusp right there. So it would be pretty clear to see that that cusp right there, the derivative would not exist. So if, again, it's got to be defined at c, and either one of these two conditions is met, so the derivative is 0 or the derivative does not exist, then we call that point c a critical value for x. So let's go ahead and take a look at an example. We're going to take a look at a graph, and we're going to identify some critical values. So let's take a look. So looking at this graph here, it says, for the following x values of f of x, shown to the right, so remember this is the original function and not the derivative. State if it is a critical value or not. In each case, justify your answer. So justification is going to be so important for this because you're going to need to be able to justify why or why not, something is a critical value. So let's take a look. -7. So where's -7? Let's see here. -7 is about right here. All right, so let's take a look. There's -7 on my graph. Is this a critical value? Well, again, let's recall our rules. So let's go back real quick, flip to our rules, and double check one last time. So the function needs to be defined at f of x, and the derivative is either 0 or the derivative does not exist. So let's take a look one more time at the example. Okay, at -7, the function is defined at -7, and of course, because of this jump here, the derivative does not exist. So is this a critical value? Of course it is. So again, our justification there is that it's defined, but the derivative doesn't exist because of this jump right there. All right, so let's check -4. And -4 is in this ballpark right here. So here's -4. Now, what do we notice about this one? Well, it's not defined at -4, is it? Okay, so could x equals -4 be a critical value? The answer is no, this is not a critical value. Again, the reasoning, it's not defined at that point, at that value of x. Let's check the next point, -1. Here is -1 right here. It is defined at this point. All right. Derivative, of course, does not exist. All right. So is it a critical value? The answer again is yes. And our justification once more, it's defined, but the derivative doesn't exist. We move on to check x equals 1. Here is x equals 1. All right, great. It's defined. What else can you tell me? Well, the derivative does not exist at this point because it's a cusp. So x equals 1 is a critical value. All right, moving right along. We will check the value where x equals 5. Let's see here. That is right here. X equals 5. So let me go ahead and notate that on my graph in case you can't see it. Well, what can you tell me about the tangent at that point? The tangent at that point is a horizontal line. So the slope then, or derivative in this case, is 0. So is it a critical value? Well, it's defined at that point, and the derivative is 0. So of course it is a critical value. So that's our justification there. Now let's look at 6. All right, here is 6. Ooh, it's not defined anywhere. Okay. And of course, the derivative obviously doesn't exist, but it violates the first rule that we were looking for critical values. It's not defined. It needs to be defined. So at 6, it is not a critical value. And let's look at our last point here that we need to check at 7. Okay, here is 7. Well, it's not defined. And of course, we do see a cusp, but again, the function is not defined at this point. Therefore, we can say that for 7, it is also not a critical value. So this hopefully clarifies your understanding of what it means to be a critical value and what it is we're going to be looking for. So stay tuned for a few more examples on critical values.
Made with Doodlecast Pro.